In this lesson, I want to talk about transformations in the coordinate plane. You know what a coordinate plane is. Transformation, many of you are familiar with transformers. It's how things change or move. So let's talk about it. You can see in this picture here that figure A, B, C, D, E has somewhat changed. It's transformed. And this is an example of what's called a rigid transformation. Rigid transformations keep the figure exactly the same. So that's why we would say figure A, B, C, D, E is congruent to F, G, H, I, J. The original figure is called the preimage. The result of the figure after it goes through transformation is called the image. So what I want to do today is look at reflection, rotation, and translation. There is a fourth transformation, but it's not considered a rigid transformation, and that's called a dilation, and that means something could get bigger or smaller. It is no longer congruent, but it is a transformation that can result in a similar figure. And then we want to graph these transformations as well in the coordinate plane. Vocabulary terms that we're going to see in this lesson. Again, please update your vocabulary as we go along if you don't already have it done. So a transformation, the formal definition is a change in the position, size, or shape of a figure. The original figure is called the preimage. The resulting figure is called the image. A transformation maps the pre-image to the image. Arrow notation, this little thing here, is used to describe a transformation, and primes are used to label the image. And I'll show you what I mean here. Look at this. How many images are copied here? Well, look at all these water towers, look at all these windows, the exact same window, the exact same space, right? Containers. These things are all around us all the time. So here, this triangle ABC, denoted this way, goes through a transformation, this arrow, and becomes A prime, B prime, and C prime. Now before I get ahead here, if I go from here to here, what am I doing? Jumping, sliding, leaping, rotating, what am I doing? So here are some rigid transformations that I do want you to get into your notes. And I want you to know the formal term and the slang because it's really important to how you describe something. So the first one is a reflection or flip, right? You reflect, you mirror, you flip. It's a transformation across a line of reflection. The line could be the y-axis, it could be the x-axis, it could be a mother function, it could be any number of things, but somewhere there's a line by which everything flips over. In this picture here, this is a reflection over the y-axis, right? The coordinate of A, the x-coordinate of A becomes opposite. We're going to do a lot more of this later on. It's just an introduction. A rotation is a turn, right? You're just turning something, and that doesn't change the figure. So the reflection occurs about a point. So you'll notice here, G is a fixed distance from P. Well, even after you rotate it, G is still the same distance from P. And that's true of all the points in the figure, right? Whether it's a triangle or a quadrilateral or whatever. Each point in its image are the same distance from P after the rotation. The last rigid transformation you should know is called a translation or a slide. You like to whoosh, slide, right? So a slide is a transformation in which all the points move the exact same distance. So if J to J prime is 10 units, well, M to M prime is 10 units, and L to L prime is 10 units. Okay? So here, a little practice here. Identify each transformation, then use arrow notation to describe the transformation. Well, M, N, O, P goes to M prime, N prime, O prime, P prime. Well, that is just a translation. So typically what I would put here is M, N, O, P, and then an arrow, and then M prime, N prime, O prime, P prime. In this picture here, what's clearly happening is a counterclockwise rotation, or a 90-degree rotation counterclockwise, right? And you'd say x, y, z goes to x prime, y prime, and z prime. Now, here's a problem that you'll see, and you'll want to graph this on the Cartesian plane. Let's try it together. A figure has vertices at a, 1, negative 1, b, 2, 3, and c, 4, negative 2. After a transformation, the image of the figure has vertices as following: a prime, b prime, c prime. Draw the pre-image and image, then identify the transformation. Go ahead and try this on your own. Pause the video, and then I'll show you the results. Okay, I've gone ahead and plotted points A, B, and C on my coordinate grid. I then have plotted A prime, B prime, and C prime. And clearly, when you look at this, you can say, oh, it is a reflection. So why did I write translation? It is definitely not a translation. It is a reflection across the what axis? Y-axis. While I'm typing this out, what happened to all the coordinates? That's right. All of the x-coordinates took the opposite of the x-coordinate to get the the coordinate of the image. So when we talk about translations, to find the coordinates for the image in a translation, add a to the x-coordinate and add b to the y-coordinate, so that if this is the pre-image, the image will go through that translation. So let's try it. Find the coordinates for the image of triangle ABC after the translation. Okay, so add 2 to all the x-coordinates and subtract 1 from all the y-coordinates. Well, that's pretty easy. And then it says draw the image. Okay, well, hold on, let's add 2. So negative 4 plus 2 is negative 2, and 2 minus 1 is 1. Negative 3 plus 2 is negative 1. 4 minus 1 is 3. Negative 1 plus 2 is 1. And 1 minus 1 is 0. Well, heck, all it says is draw the image. I can do that. So let's go ahead and grab a little line tool. I think you guys will like this. I'm going to start it. There we go. We'll do that nice and clean, make it look real pretty. So we're going to start at negative 2, positive 1. And then from here, I'm going to go to negative 1, 3, 2, 3, right? And then from negative 1, 3, I'm going to go to 1, comma 0. And then I just need to go back again. Right? Draw the image. And if I was going to label this appropriately, I would say negative 2, 1 is A prime. Negative 1, 3 is B prime. And this one right here is C prime. I think that's about all I really want to show you in this. Let's take a look at one more maybe. Yeah, let's just take a look at one more and then we'll call that a video. So the figure below shows part of a tile floor. Write a rule for the translation of hexagon 1 to hexagon 2. All right, so this is hexagon 1 right down here. Right? This figure here is hexagon 1. They put a little 1 there. And they want you to go from 1 to 2. Well, how do you figure that out? Well, what they're suggesting is take one single point, like this point in yellow. Hope this shows up for you. So get this point in yellow. We're going to call that point A. Well, what do you have to do to go to this point? Let me make this one orange. You guys like orange, right? So I'm going to go from yellow to orange, right? What do I have to do to go from A to A prime? Well, it's simple. I have to go over 1, 2, 3, and I have to go up 1.5. Now, you have to be a little bit careful here because it says A has a coordinate of 2, negative 1. Okay, I agree. And A prime has a coordinate of negative 1, 1/2. Well, the rule, I would say, okay, to go through, I would say the rule is x, comma, y goes through. What do I need to do to x? I need to x, how do I translate it? I have to subtract 1, 2, 3. So x minus 3. I feel like I'm writing like I'm in 3rd grade. And then comma, y. What do I have to do to y? Well, I'm going up 1.5. So plus 1.5. And so this is an example of now we're writing a rule from a diagram or from a pattern. You should be able to now go from a rule to a pattern and from a pattern to a rule. So today we talked about transformations, which rigid transformations maintain congruency, and those rigid transformations are translations, rotations, and reflections.